Hi, Yasmina, and hi, everyone. Thanks so much for showing up. I see we have people from all around the world, so lots of different time zones here. I really appreciate you taking the time to talk about some development stuff today. So there's a lot of stuff to go over, so let's get started. I don't want to linger here too long, but I'm Greg Shackles. I work for a company called OLO Online Ordering in New York City. If you need to get in touch with me, here's all my contact info, my Twitter account, GitHub account, where I have all the sample code that we'll go over later in the talk, my blog, and all of the slides that you're looking at now are already available on my speaker deck account, so you can get them at that URL too. Or if you just go to my Twitter or something after the session, I'll be sure to tweet everything, so you don't need to hurry to write everything down right now. And I do, on the same topic that we're going to talk about today, I recently published a book with O'Reilly called Mobile Development with C#. You can get it at this URL, and it's today's deal of the day, so you can, there's a nice link to it right on O'Reilly's, the front page of the site with a discount code, or you can use this discount code here for 40% off the print book or 50% off the ebook. And that's enough self-promotion. So let's just start diving right into the content. So the mobile market right now is very varied. Just looking at the U.S. market share, ignoring the rest of the world just for the sake of simplicity here, about half of the market right now of smartphones is Android, with Apple holding about a third, and then RIM falling a few percentage points every month, and Microsoft kind of holding steady. So if you're looking to get into mobile development, there really isn't one platform that you can target and get everyone that you need to do. So you're going to be at least needing to target Android and Apple, Android and iOS, and maybe Windows Phone as it starts to gain more traction in the next year or two. So then the question really becomes, how do you do that? How do you easily target all these different platforms? So then you take a look at the native platform languages and the SDKs that each vendor puts out and how you're supposed to do your development for each of them. On iOS, Apple provides SDKs for building applications in Objective-C. Normally you build Android applications in Java, and then on the Windows Phone platform you mainly make use of the C# language. So they're just programming languages, but they're three very different programming languages and three very different platforms. So you can't really, you'll end up solving the same problem on each platform that you want to go to. And obviously, this, as developers, this is less than ideal for us. Solving the same problem 3 times means you might have the same bug in 3 different places. You have to do 3 times the amount of work just to get everything done, and that can take a long time and just be error prone. So then that, as developers, that leads us to start looking at other solutions out there, some cross-platform development solutions that might help us share more code between the different platforms and get our apps out there more quickly and more stable. So generally, the first instinct a developer has is to look for some kind of write once, run anywhere solution. This was Java's big promise back in the day, but it definitely has its pitfalls, and today we're going to talk about an approach that's much different than the write once, run anywhere approach, and we'll kind of go over what the difference is and what the advantages are. But really, the big disadvantage of doing some kind of write once, run anywhere approach, especially towards mobile development, but really any kind of consumer user-facing application development, is that you end up building towards the lowest common denominator between all the different platforms that you want to do. So you end up shoehorning in something that doesn't really feel it's not going to feel native to the user. It's not going to feel right. It's not going to feel at home with the rest of the applications that user has on their phone or even their desktop, whatever environment they're operating in. So you really have to keep in mind and be conscious of what you're abstracting. You don't want to be abstracting away the user's experience, because then they're not going to enjoy your app. They're not going to use your app, and then you pretty much have lost them at that point. So write once, run anywhere it sounds great to developers, but to the end user, you're really making sacrifices that you don't need to, and it's just going to lead to more heartache in the end. And the other side of that is that each of these different platforms is a very different creature. And that's something that I feel should be embraced rather than abstracted away. So if you take a look at, even ignoring the UI on each platform for a second, if you just take a look at these three different devices, just the hardware. On the iPhone, you have the single button at the bottom that kind of does a little bit of everything. On Windows Phone, you have the three buttons down there for back and home and search. And on Android, you have the 3 or 4 main buttons depending on your platform. And on top of that, you have different sizes. The iPhone size is pretty fixed, so it's easier to develop basic UIs there using absolute positioning. Windows Phone has a few different sizes that the device can be, a few different resolutions. And on Android, there's probably 100 different configurations you can have. So trying to abstract that away and create something that, some lowest common denominator between them is just you're going to lose a lot of what each platform has to offer. And on top of just the UI problems there, you'll start losing out on individual features that each platform has that you really want to take advantage of. Say on iOS, they have Twitter integration built right into the operating system, and iOS 6 is introducing Facebook integration. So if you're on iOS, that's something that you should want to take advantage of and give the user a really rich experience where the platform allows for it. Android has its NFC integration built into the newer SDK levels. So you might want to take advantage of that, or say you want to use live tiles on Windows Phone. Each platform kind of has really cool things that you want to take advantage of, so you want to stay native and act like a normal application on that platform whenever you can. So now we've talked about the fact that all these platforms use different languages, but we don't want to abstract away the UI. So what can we do to not have to repeat ourselves on every different platform, but still deliver a completely native experience to the user? And today we're going to talk about how you can leverage the C# language and the corresponding .NET platform and .NET framework in order to go really far and build completely native applications. So the way we do that is on Windows Phone, it's obviously still the native route. So normally you build Windows Phone apps in C# and .NET, so that's no different. But on iOS, you can take advantage of a product called MonoTouch, and on Android, you can take advantage of a product called Mono for Android. And using these, you can actually build completely native applications for those platforms, but build them in C#. And we'll later on in the talk, we'll start going over exactly what these products are and how they relate to the platforms and what they're doing. But at a high level, this is the approach that you would be taking. But first, let's dig in really quickly to just why C# is a really good choice for doing mobile development or any kind of development, really. For one, you get access to the base class library of .NET, which has all sorts of functionality built in for doing most common tasks that you'll need to do, be it file access or basic database access stuff, or accessing the network and string manipulation, all these kinds of things. You get access to this really established, mature framework that's there. You also get access to advanced features in the language, such as link and link over objects, link to XML, and you even get parallel link access, which gives you, it allows you to take advantage of easily take advantage of devices that have multiple cores. So if you want to start running a really CPU-intensive process over multiple cores on a device that has multiple cores, such as the newer iPhones or iPads, you can really easily do that without having to get really low level in your code, just using the built-in language features of C#. You get memory management. So in C# and .NET, if you're experienced on those languages already, you'll be used to having things like garbage collection and memory management, and these things are abstracted away from you, and you generally don't have to think too much about them. Especially on iOS, this is something you do have to think about because you don't have normal garbage collection. But MonoTouch actually brings in garbage collection with it. So you get to take advantage of features like that while still building your native applications. You also get features like the task parallel library, which allows you to really elegantly write asynchronous applications, which is very important when you want to keep the UI of your applications responsive, but still want to easily be able to create threaded applications and manage background processes and things like that. And you also get, in certain cases, some of the dynamic features of C# that have been added in more recent versions. So what it boils down to really is that C# is just an extremely powerful programming language, and to be able to take advantage of that on all of these platforms is pretty awesome. So let's take a quick look at those tools that I had mentioned before. So MonoTouch and Mono for Android are produced by a company named Xamarin. You can find more info about them and the products at xamarin.com. But what they give you is full access to the platform SDKs. So this isn't, it's not really an abstraction in the way that most platforms are, that most toolkits are abstracting away the platform. What you're getting here is full C# bindings to the native SDKs. So classes have the same names, they're the same namespaces. It's all the same things that you would read in, say, the Objective-C documentation or the Java documentation for Android. But you're accessing all of that through C#, so you could take advantage of all the C# and .NET features that we had talked about previously, while still getting everything that a native developer in Objective-C or Java would get. And like I said, your app would remain 100% native because you are using these native toolkits. Just because an app looks native doesn't mean it feels native. You know, just because a button is colored and shaped kind of like an iPhone button doesn't mean that it feels like one, or that, you know, the user's going to be happy with how it acts and it'll act like all the other buttons on that platform. But in the case of using something like MonoTouch, the button will be a native button because it's still compiled down to the exact same code, the exact same assembly code behind the scenes. So you don't actually have to worry about that because there is no UI abstraction. You get what's called a linker, which is a built-in build process that, so the .NET framework is obviously very extensive, and you don't want to have to ship the entire framework with the whole base class library with every mobile application you put out there, especially because these mobile devices are pretty resource. They don't have the resources of a desktop application. So this feature called the linker will actually go through as a post-build step, analyze your application, and strip out any pieces of the base class libraries, or really any libraries that you pull in that you're not accessing. So you're only shipping with the code that you absolutely need for your application to run, and nothing else. And as you can imagine, that helps cut down on the code size, the application package size substantially. They also release very frequently, so they keep up very quickly with new SDK releases. So usually within 2 or 3 days or so, you'll find a new release. When iOS 5 came out, within a day or two, they had full iOS 5 bindings. And on top of that, they're constantly releasing with new features of their own, and getting community feedback and iterating on that. So they're very, very nice tools to work with in that they don't sit there stagnant for a long time. There's constantly updates, constantly new great things that you get at your disposal just for using the products. There's also a very active community. So between things like the mailing lists and IRC and Stack Overflow, community events, they're very engaged, and there's lots of awesome people even outside of Xamarin itself that are very active and very helpful, and so there's a lot of support out there, which is great. And as I mentioned before, I don't actually work for Xamarin, so I'm just a happy customer. And one of the big things that these tools give you over the native languages is often the API that they expose through these bindings is nicer to work with than than the native ones. And we'll go through an example in a second. But so what they do when they can is try and take some of these APIs that are exposed from Objective-C or Java and wrap them up into something nicer that's a little more .NET friendly. Certain language features don't necessarily translate, say, between Java and C#. So they actually take the time to wrap these up in a much nicer binding that makes it much more C# friendly and often much nicer to work with, even in general, than the native ones. So we can look at a quick example here. We're not going to go too in depth into the samples, but basically this is a quick code sample that creates an attributed string. So it creates a string that has a font and a color. It's not super complicated code, but it's also not pretty code. So it's kind of old school looking because it's very, it's Objective-C, so it's C-based. But if you want to do the same exact functionality in C#, it's a much cleaner interface, much more readable, but much more maintainable. And if you've worked with C# before, this is going to look a lot more familiar to you. And then if we take a look at the Java side, there's two pieces of this sample here that you could look at. So like most Java applications, Android apps have a fair amount of XML configuration that has to happen with them. So the top XML example here is an example of what goes in what's called the manifest, which is where you register all of your components that make up your application so that the OS knows about them and knows how to deal with them. And then the bottom sample here is how you would find a button in your UI and attach a click listener to it. So it's very verbose, as you can see. You find it in the UI, then you set an on-click listener, and then inside of that you create a new on-click listener, override its on-click, and then finally, 6 lines later, you get to actually write the code that you want to write. In C#, this is substantially cleaned up. So they introduce attributes for many things that at build time will generate the XML that you need for you. So that one attribute line would go on top of your class, and it would generate the exact same XML that you see at the top. And then for the bottom sample here, you could see that the names are cleaned up to look more .NET-like as far as function and variable casing. There's a nice generic version of find view by ID here. And then the big thing here is that the click listener is replaced by an actual event on the button class. So all you need to do is subscribe to this event, send in a delegate or some kind of handler function, and then, handle that click however you want. So it's a much cleaner interface and much more friendly and much more familiar if you're already familiar with the programming in C#. So let's take a quick look at what the environments look like that you need if you want to build these applications. So all Apple-based development requires having some kind of Mac. So that's not something that you can really get around easily. You can possibly use a Mac that's hosted up in a cloud. There are some services that do that. But one way or another, to build an iOS application or even a Mac OS X application, it needs to be done on Mac OS X. So one tool that Xamarin provides in doing this is a tool called MonoDevelop. So if you're familiar with Visual Studio, MonoDevelop will feel very, very familiar to you. It's their open source development environment. It's very full-featured, and this is what you'll be doing all of your development in if you're on the Mac and doing Android or iOS development. And they actually integrate fully with Xcode, which is Apple's IDE for doing Objective-C development. So Xcode also includes a UI designer. So you'll see this later when we start digging into some code samples. But MonoDevelop and MonoTouch actually hook into Xcode for its UI designer. So you'll switch over, use the native UI designer, all the native stuff that you're used to, or that native iOS developers are used to. And then once you hit save, all you have to do is switch back to MonoDevelop, and it already knows about what you just put into that UI, and you can access all of that stuff from C#. So it's a very, very clean integration there. And then over on the Android side, you have a few more options. Like I said before, you can use MonoDevelop on Mac OS X. So that's, MonoDevelop is completely free, so and it works on Mac or Windows. So even if you are on Windows and you don't have a Visual Studio license, you don't need to buy Visual Studio to do this stuff. You can just download MonoDevelop for free and get full access to the IDE there. But if you do have Visual Studio already on Windows, and it has to be Visual Studio 2010, one of the full versions, the Express version doesn't expose the plugin architecture needed for Mono for Android to work. But if you do have that, the Mono for Android Visual Studio integration is fully baked in and works really nicely. So you won't have any problems there. And one of the features that Xamarin released recently is their UI designer for both MonoDevelop and Visual Studio. A UI designer is one area that Android in general is just really, really lacking in. And Xamarin kind of knocked it out of the park with this really full-featured, awesome UI designer that, like I said, it works in both Visual Studio and MonoDevelop. So you have a nice drag-and-drop interface to build up your views and layouts and all that kind of stuff. And if we have time at the end, I'll also show what this looks like. But it comes, just as part of the package when you install Mono for Android now. And then on Windows Phone, you need a Windows machine and you need Visual Studio. So it's a much simpler requirement here. If you don't have a full version of Visual Studio, they do actually provide a nice Express version, which gives you everything you need to do Windows Phone development. So you don't have to worry about paying any money there. And here, just real quick, are some nice example applications built using MonoTouch and Mono for Android, just to kind of, lend a little credence to the platform as a whole. I don't want to spend a lot of time going through each of these, but they're definitely worth looking into to see. This is by no way an exhaustive list. Of everything that's on the platform. There's tons and tons of stuff out there built. So I just kind of handpicked a few of them to call out here. But these are really, really nice applications that kind of show that MonoTouch or Mono for Android provide really nice native applications and not some UI abstraction. So let's quickly go through some of the benefits that you get of using this approach. So as we mentioned earlier, some of these will be repeats a little bit. C# is a very, very powerful, very mature language. It's been around for over a decade now and has, it's matured a lot. It's really kept current. So you get to take advantage of all of that in your applications. You get to reuse the skills that you develop in that language across all these platforms, and that's not a trivial thing. Just having the context switch between Java and Objective-C and C# could drive you a little batty. So being able to kind of learn the language, learn the namespaces, and be able to hit the ground running, really developing fully native applications on 3 different platforms is a really, really powerful thing. And like I said, these apps are 100% native, so it's still all the native toolkits, it's still the native UI elements, it's completely native applications. So the user would have no way of knowing that this isn't, it wasn't built in Objective-C or Java, for example. And then the big thing here, and we'll start digging into this a little bit, is that even though you're still developing these native applications in the native UI toolkits, there's still a lot of opportunity to share a lot of your code across all these different platforms. And that's not even limited to just mobile platforms. So we're not just talking about iOS and Android and Windows Phone. But once you take the right approaches, and we'll dig into this a little bit, you can reuse a lot of your application code across any C# friendly platform. So you could take it into a WPF application or an ASP.NET application, the Silverlight application. Really anything like that. So this becomes a really, really powerful way to make sure you only have to repeat the hard work once and then just build UIs on top of that later on. So following that, this is a quick look at what your architecture would look like if you want to maximize how much code you can share. So you would write your business logic in one layer in C#. And as much as possible, the trick here is really just to make sure that you can separate your business layer, your application's core logic layer, from any kind of UI or presentation layer. Once you create a coupling between the business logic and the UI, you have code that can't easily be shared because it's very specific to a certain platform. But if you can keep those independent from each other, you can, that code can go to any platform and be useful on any platform. And then what you end up doing is, on Windows Phone, you'll build a Silverlight head for the application, and then under the hood, it'll use all of your shared business layer, but it'll still have its native UI on top of it built for that platform. And the same goes for MonoTouch and Mono for Android. Those would basically act as the presentation layer that gives you access to your shared layer and all the native platform toolkits. So let's take a quick look now at kind of what kind of code can be shared in your application. Like what code lends itself well to being written once and then reused across these different UIs. So as I said before, most non-UI or platform-specific code will probably already be ready to share across many different platforms at once. This usually applies to your core application logic and the heart of what your application is doing. This can be your business entities that you don't need to rewrite. This can be link code, link to object, even link to XML, so you can do really complex XML parsing using the nice link to XML APIs and reuse that across all three platforms without having to rewrite a single line. You get nice network access APIs right through the .NET base class library, and those are fully capable, fully supported on all three of these platforms as well. So you don't have to write networking code 3 different times in 3 different platforms. And you can even do file and database access code sharing in certain scenarios. I have a little caveat here that says some limitations because Windows Phone doesn't give you direct file access, but you can use things like isolated storage, which is supported on all 3, to give you a unified file API across all of them. And the database access story is a little bit different between Windows Phone and iOS and Android, but it is still very possible to share 100% of your database code too. You just have to kind of bring in a couple libraries. So I don't want to dig into that too much, but it is mentioned in the book, and there's actually a great blog post by Xamarin, who, when they built the MWC 2012 mobile app, where they dug into how they shared a lot of code between the different platforms. So I would definitely recommend going to the blog.xamarin.com and checking out that there. So file linking is basically an approach you can take to share a single copy of a file across multiple projects without having to copy and paste it between different folders and make sure that you update the same line of code 3 different times, in 3 different versions of the same file, or use any kind of, say like source control tricks to copy the file over. What you can actually do is just add a reference to the file in your project, declare that it's a link rather than a copy of the file, and then at compile time, it'll actually bring in that file and compile it as if it was part of that actual project, but really it's just looking at the version of the code that's sitting off in some other folder that you link to. So this becomes a nice way to create multiple projects that target each of the different platforms, but not have to repeat yourself and not have to do the same work a few different times. You also can take the abstraction approach, which is a tried and true development practice here. So you can, if there is something that needs to be implemented specifically for each platform, say like a geolocation library that goes out and uses the native APIs to go pull in the user's location, maybe the business layer doesn't necessarily need to know how that's happening. It just needs to know what the result is. So you can use things like interfaces and base classes to kind of abstract that out, and each platform can plug in its own way of doing things, but the business layer can just rely on the contract and the result there and not necessarily need to know specifically how something is happening. The observer pattern is another practice you can follow here, and like we saw earlier with the button click example, the observer pattern basically has you can expose events on your classes and raise them in your business layer when things happen, and then all your UI layer needs to do is subscribe to these events and react to them. So say a download in your application finished, your business layer can fire off an event that say, hey, the download's done, and then your UI can listen for that and react to it. But that means that the business layer doesn't need to know anything about what happens afterwards. It just publishes an event and moves on. So it's a really nice way to decouple your applications there. You can also do partial classes and partial methods, which are a C# feature that are pretty nice. It basically gives you a way of defining a class across multiple different files. So you can declare something as a partial class, and the base implementation can have things that work across all the different platforms you need. But then each individual platform can actually plug in specific logic that it needs or kind of fill out the class in platform-specific way. But then at compile time, they all get pulled in as part of the same compiled class. So it's a nice way to kind of separate that out as well. And then another method is just straight up conditional compilation. So you can conditionally say only compile this line of code or this block of code if this is being compiled for Android or if this is being compiled for Windows Phone. And it gives you kind of a way in line of quickly opting in or out on different platforms if you know that a certain feature isn't supported. This can get kind of messy, but in certain situations, this can be really powerful. And then another up-and-coming method that you can do, and this isn't fully supported right now in MonoTouch and Mono for Android, but it's something that they are actively working on, so I wanted to mention it here, which is called portable class libraries, which is basically a way of taking the common part of all these different platforms, say the lowest common denominator of the base class library, and allowing you to create a single DLL that can be shared across all the different platforms without you having to worry about which platforms do or don't support which pieces of the framework. So in this case, you wouldn't need to worry about file linking and things like that because it would be the same copy of the DLL every time. But this isn't something that's fully supported at the moment. And I just wanted to mention this one library that Xamarin is, I believe it's still in beta right now, but it's a really nice abstraction library that they're working on called Xamarin.mobile. And this basically takes the abstraction pattern that we talked about on the last slide and applies that to a lot of common things on all these different platforms, such as the contacts APIs, geolocation, camera APIs, the notifications, and things like that. So a lot of these are things that you don't necessarily need to use. They're not necessarily UI-based. They're just application logic-based. So this library kind of aims to provide a nice abstraction level over all three of these platforms so that you can even start sharing a lot of your, say, contacts API access code across all these different platforms. And on top of that, as is the case with a lot of these things, the API that they expose, for example, for contacts is infinitely better than the API that native Android SDKs provide for Java. I mean, it's pretty painful on that side, but it's really nice to work with through Xamarin.mobile. So I definitely recommend doing that as well. And on that note, let's see, how much time do we have? So I can jump into, I just want to go through a quick demo of how to set up kind of a shared project and pull that into, we'll at least run through a MonoTouch application, and then I'll see if there's any questions and things like that. And if we have more time, I can do Android as well. So let me switch over to doing a screen share here real quick. So this is MonoDevelop, the open source IDE I mentioned before. I'm on a Mac right now, so I'll be using that for my examples. Visual Studio works in a very, very similar way. So what we're going to do here is create a very simple weather checking application. So it's going to go off, hit a web service, ask it for the weather given a zip code, and then just display the temperature and the current conditions in the application. And along the way, all of the code that actually accesses, like the model code and the web service access code, that's all going to live in a shared layer, so it's going to be independent of the actual iPhone application and it'll be completely shareable across all the different platforms. So what I'm going to do here real quick is just create a blank solution. So I have a blank solution, and then we're just going to add a new project here. It's just going to be a standard C# class library, so just a standard .NET class library. This has nothing to do with any mobile platform right now. And we'll call that Weather Core. And create that. And you can see if I go to the project properties here, of course, at demo time, my Mac decides to start doing things. But you could see that it was targeting .NET 3.5. We can even say target .NET 4 to get some more APIs. And then now this is a .NET 4 class library. So what I'm going to do now is I'm going to add a new class. We're going to say Weather Service. So we create a new class here, and I'm going to cheat a little bit to make the demo easier. So there's our weather conditions model class. It's just a very simple POCO that has an integer for the temperature and a string description of the current conditions. And then we have our web service class, and I need to add some references here. So if I go in, you see we're going to access system.xml, system.xml.link. And then, so I need to pull in system.net using system.xml, using system.xml.link. So you could see here, let me just fix the references here. I have to pull in typical demo stuff again. So we do that. This should build. Anyway, actually, since we're running short on time, what I want to do is just open up really quick. Sorry, bear with me through this demo. This is pretend that never happened. So what we're going to do is open a solution, go to okay. So like I said, the sample for this is completely up on GitHub. So it's, you can go check this out, download it now, run it in the simulator. So we can take a look at Weather Core here. So in the weather service, we have, we new up a web client class, which is just a built-in .NET, network access class. We give it the URL for Google's weather API, sending in a zip code, and then parse the response down here using link to XML. And you can see we even take advantage of .NET's nice functional capabilities that were added in later versions of C#. And then all we do here is just parse that out and send back a weather conditions object that that just has the temperature and the description there. So instead of doing this, I'll just create a new project here so you can see what it's like to start from scratch. And then we'll say create a new single view iPhone application and call this Better iOS Weather App. So you can see in the project here, I'll expand this a little bit. So in the default files, we have the view controller C# file, which is the class file, and then a view controller.zib file here, which is the Xcode interface builder file. So iOS applications generally follow an MVC kind of approach. So any screen in your application is generally going to correspond to some kind of view controller. So what we can do first here is if I double-click on the zip file, you can see that this opened up in Xcode Interface Builder. So if we want to quickly build up some kind of UI for it, I can just drag controls over and say, enter the zip code. We can put a text field here, and then I'll just quickly run through and say temp conditions, and this is going to be kind of a terrible looking UI, so because in the interest of time and not trying to spend a lot of time on the details here. But you can see how this will be a very basic UI for showing basic temperature conditions. And then we'll also need a button here that you can click to say go off and get the weather conditions. So check weather. So this is our UI right now. And in Interface Builder, there's two different ways that you can expose pieces of the UI to your, the back end of your application. And those are called outlets and actions. So what you can do, if you want access to the control itself, you can define what's called an outlet, and then you'll get access to, say, the text field or the button in code. Or if you only want access to a specific action on an event, say the button click event on the button, you can define that as an action. So we'll do a little bit of both here. So you can see if you hold down control and you drag it over to the class here. It's a little bit of a weird interface, but this is how Xcode likes to do it. And this allows me to create an outlet for the text box now. So I can say, call this outlet zip code because it corresponds to the zip code text box. And now that's created there. And then we can do the same thing. I can define select action from the list, call this action check weather, and then add that to the class. And then I'll really quickly do that for the other labels here. So create outlet for temperature, and then I'll create one more for conditions. And then all I'm going to do here is save this down and switch back over to MonoDevelop. And what you can see is if you look in the designer file here, hold on, I don't think that's saved. If you look in the designer file, you can see that it actually created, using this partial class method that we had talked about earlier, properties for the different outlets we defined and a partial method here for the action we defined. So now we have full access to those objects in our view controller code. So what we're going to do here is I'm going to add a reference to the Weather Core, the iOS version of the Weather Core app, and then I'll say create an instance of weather service inside the class, and then we'll just new that up in the constructor. Oops. And you can see that this is a fully featured IDE with code completion and all that kind of stuff that you'd be used to in any high-quality IDE. So it is really nice to work with. Equals new weather service. And then what we're going to do is just override, provide the implementation for that check weather partial method here. And we'll just say, so if there wasn't any zip code provided, we'll just show an alert to the user and then dump out of this method because we don't need to go out to the web service if they didn't actually input anything. So you can do that in iOS by saying, the alert equals new UI alert. And I'm just going to show that alert and then return out of this method. So what that'll do is it'll just pop up a little alert using the native alert box stuff that's built right into iOS, show them an error, and then we can just dump out before ever hitting the web service. And one thing I wanted to make note of here, if I look at the weather service, you could see that the way I define this API for get weather is that it has a return type of void, and then one of the parameters to this method is a callback that sends back the action. And the reason for this is one of the things you need to make sure to do in your applications is that you want the UI to always remain responsive. And if you make a long-running, say, a web service call or a database call or a file system call on your UI thread, that's actually going to lock up your application for the duration of that call. So what you want to always make sure to do is to run long-running things like this in the background and just call back up to the UI once that work is done and you need to make UI updates. So in this case, you could enforce that in the app itself, but in this case I decided to actually enforce that in the shared API itself so that each app doesn't need to worry about calling that explicitly on a background thread. It can just assume that that's what's going to happen. So all I need to do here is say weather service.get weather, get the text from that zip code, and you see we're just accessing that text field as if it were any other object on this class. And then we just have to implement the callback function here. And one thing you always want to make sure to do is that once you have updates to do on the UI thread, you just want to marshal those up to explicitly up to the UI thread when you can. So you can do that on iOS using a method called invoke on main thread. So all we need to say here is that temperature.text equals weather.temperature, temperature.toString, and then conditions.text is weather.description, and build that. And then that's actually all the application itself needs to do in order to do it. So I can launch that right now in the iPhone simulator. You see if we do this, you get the nice native error saying to enter a zip code. And if I enter zip code for New York here, you can see that it pulls back, updates the UI with the temperature, and then updates the UI with everything it got back. And the UI remains responsive in the meantime. If you wanted, you could pull up some kind of native loading dialog and keep that all platform specific. But because all of this code was shared, all of the real heavy lifting was shared in that in the Weather core project, the application itself only really needed to give a UI on top of it in order to expose that to the user. It didn't need to worry about anything else that happened under the hood. And you can imagine in most applications, the logic that would sit in Weather core for, say, a weather application would be a lot more extensive than a single web service call. But for the sake of a simple demo, I think this demonstrates it pretty nicely. So I could show the Android version, but it's probably worth checking if are there any questions that we should address first, since we're running up pretty close to an hour now.
Sure, Greg. We actually have several questions that have come in, as you can imagine. I'll just take them in the order they came in. We have a question from Kay. Kay would like to know, any chance to use Develop for Windows instead of MonoDevelop or VS?
I'm not familiar with that IDE, but I'm pretty sure the answer is just no. So Xamarin provides the actual plugins for Visual Studio 2010 and for MonoDevelop. So those are pretty important for building out MonoTouch or Android applications. So generally, I wouldn't expect support for anything outside of those IDEs. Great.
We have a question from Lucas. Lucas asks, how does this compare to tools like Titanium by AppCellerator?
So tools like AppCellerator, Titanium, they're pretty nice, but they take that other approach to cross-platform development kind of that I mentioned towards the beginning of the talk, in that they try and provide more of a UI abstraction than this approach takes. So whereas I believe AppCellerator lets you program in JavaScript, so they try to provide kind of as much as they can a write once run anywhere type solution where you can, say, compile your app for Android and then compile that same app for iOS and then publish your app on those different platforms. Whereas with this approach, with C# and the Xamarin tools and the native Windows Phone tools, you'll end up building your core application once. It becomes a lot more testable and reusable, but you'll still end up learning you'll end up learning all the individual platforms, which personally, it's more work, yes, but personally I think it's a very good thing. Like you should have a good understanding of the platforms you're targeting. And at the same time, you still get to develop a 100% native application for the user without having to abstract away any of that experience.
Thank you. Another question here from Alex, and again, this was a little bit earlier on. How does it apply to WinPhone 8 development? For example, Metro apps for ARM-based tablets?
So I would say that falls into the category of some of the advantages of just this code sharing technique, this approach to architecting your applications. Like these tools don't necessarily have a direct play on building Windows 8 applications or tablet applications for Windows 8 and that kind of thing. But again, because you'd be architecting your applications in such a way that a lot more of your code is platform independent. It's just using the standard C#-based libraries, and it's just it's not tying itself to any particular platform or any particular UI paradigm. It would lend itself a lot better to reuse on any new platform, such as Windows 8.
Great. Question now from Andreas. How mature do you think Xamarin Mobile is, and what's your guess when the library will be maturing out of beta status?
Okay, so that's two parts there. As for the maturity of the Xamarin products, they're extremely mature. Especially MonoTouch. MonoTouch has been around for a few years now. Mono for Android is a little over a year old, so it's definitely the younger of the two products. But over the course of that year or so, it's definitely grown up a lot. With MonoTouch, again, it's been around for a few years, so it's had a long time to mature. And they're very. I find them both to be very stable platforms. If you do find bugs, it's really easy to get a hold of the developers. The support is awesome. Not that you'll end up running into a lot of bugs or anything, but if you do run into problems or need support, the support is really good. But I do find them both to be extremely stable products and a much nicer thing to work with. And as for the second part for the Xamarin Mobile, I don't personally, I don't have any insight into what the roadmap is for a maturing product. I know that it seems like every few weeks or every month or so they're releasing kind of a new piece to that puzzle. So there was the contacts API and then geolocation and then camera. So I know at some point that they'll probably end up merging that upstream into the main product, but for now it remains kind of just a separate piece. But I'm not sure on what I'd expect the timeline to be for it to get out of beta. But that said, it's definitely at a point where you could try it, and if it has the functionality you need, then by all means, I would suggest just jumping in and starting to use it.
Great. Thank you very much. A couple more questions here. We have one from Kay. Is cross-platform barcode scanning possible with Xing or Xing or any other library?
I'm not sure really on the cross-platform part there. I haven't dug into barcode scanning much personally, but I imagine that if all you needed was an image and then the image just had to be processed in code, I imagine that you would be able to do some kind of code sharing there. The current story is with libraries like zebra crossing, but in theory it would be possible to write that independently of the platform, but I'm not too sure what the story is at this moment.
Great. Another question here. How about Windows Phone 7.5? How do you see the future of that platform, or will there be a completely new defined Windows Phone 8 platform?
Now we're diving into personal opinion, so everything with a grain of salt. But I personally think that the Windows Phone platform is going to do really well in the long run. It's really nice to work with. It's really nice to use. And I think Microsoft really hit it out of the park on some of the features there and the usability, and really kind of rethinking what a mobile UI should be like. I do think it's going to take some time for it to gain adoption. Adoption has been extremely slow for the last year, 2 years, however long it's been out. My hunch is that the next couple of years it'll start to gain some decent market share, especially once Windows Phone 8 comes out. And keep in mind, Windows Phone 8 isn't really changing the UI of Windows Phone. It's just starting to add in a lot more powerful features for developers, which is awesome, like things like app-to-app communication, so your apps aren't acting in like a silo like they are now, and a lot more security features and things like that are keeping big corporations away from adopting Windows Phone as their platform. So I think there's a good future in Windows Phone, and just like this to building your app will only continue to benefit you, especially if that keeps happening.
Thank you very much. And we have one final question here we have time for from Sandy. This was during your demo. She'd like to know, which IDE were you using?
So the IDE I was using in my demo there was that was just MonoDevelop. So it's running on my Mac here, but it runs on Windows as well. So it's Xamarin's free IDE that fully featured and supports a lot of things, but in particular for mobile development, it supports both Mono for Android and MonoTouch as first-class citizens.